The nice thing about logarithms is that when you get the question, they give you the formula and they describe what each thing stands for. So you would get not only this formula, but it says that FV stands for the future value. So in this question, it says the future value is $100,000. So we would know that we could write in $100,000 equals. They would tell you that R was your investments, and we're told that we're doing monthly investments of $200. That I is the interest rate as a decimal, so we would put in 0.0, actually, I is the interest rate as a decimal divided by the number of compound periods. So we would put in 0.06 divided by 12 because it's compounded monthly. The exponent n is the number of payments minus 1 divided by 0.06 divided by 12. So what makes this formula a little bit more complicated is, again, we're solving for n. N is in the exponent. We're going to need to use logarithms because I'm pretty sure we don't know bases that are the same here. We're going to need to use logarithms. And before we use logarithms, the whole thing that we had from before is, can you first just do algebra to get the power by itself? And this is grade 9 algebra, even though the numbers aren't nice. So if I want to get that by itself, I'm going to need to move this over, and this over. Can you see that those three things that I circled would have to be moved to the other side before I have the black box power by itself? So now comes your order of operations into play. Grade 9 order of operations. What would you do first? What am I allowed to do to make this more simplified? Now, I personally would get rid of the dividing first. We've got a big fraction. I would multiply both sides by 0.06 over 12. This side by 0.06 over 12. Can you see that that would cancel out that part? Go to my calculator. These are always calculator questions. 100,000 times by 0.06 divided by 12. 500. Nice number. So I have 500 equals 200 square bracket, round bracket. 1 plus 0.06 divided by 12 to the n minus 1 square bracket. Next thing I would do, get rid of this 200 by dividing both sides by 200. This will give me 5 over 2, or 2.5 equals, and can you see at this moment that those extra square brackets are no longer needed, right? Because you've moved all the other stuff away. Now I would just have 1 plus 0.06 divided by 12, the n minus 1. I can add 1 to both sides. I can scroll back up. Very good. Is that far enough? Yeah. Okay. Now we've got our power by itself, which is really helpful because now we can take the log of both sides, or the natural log. Either one would be fine. Take the log of both sides. You'll get log of 3.5 equals, the n could come out in front now because your log law says if you take the log of that side, exponents can come out in front, which is really handy because now we can get n by itself And we can go to our calculator, type this in, and not only can we type it in, we can also check with our original equation to see if it is correct. So we'll wait for the calculator to warm up here. No thanks. Log of 3.5 divided by log Now, the question says, how many monthly investments would it take? Well, the answer is 251.17. Does it make sense that 251 wouldn't be quite enough? Even though it rounds nicely to 251, we'd actually have to say it would take 252 payments. So we can write here n is 251.17, and as our it would take 252 payments. It's kind of like if you're painting the walls in your room and it's going to take 1.1 cans of paint, you can't buy one can. It wouldn't be enough. Or you just have to not paint behind your bed or something. I hope no one ever moves your bed around. Then it'll get bigger. So it would take 252 payments. So this is how you would solve this algebraically. And this is what would be expected on your exam, to solve it algebraically. Now, these kind of questions happen so much in real life that online, and if you have a graphing calculator, your graphing calculator, a lot of apps are available to do this same thing. So for those of you that have graphing calculator, I'm going to show you, if you hit the apps button, the very first one says finance, and the very first one, TVM, time value money, is a very, very helpful app for figuring out all sorts of things to figure out. Okay? If you watch one of my other videos, I would explain it more in depth. So if you wanted to write notes on it, you can pull up one of my older videos. Because we're short on time, because the exam's coming up, I'm just going to show you how it works. So we were solving for the number of payments. Our interest rate was 6%. Because it's written as a percent, you could just write in 6. You don't have any money there in the beginning. You want to get $100,000 in the future. And you're making payments of $200. Now, in this program, it has a little finicky part saying, whenever you get something, it comes to you in a positive amount. But whenever you put money from your pocket away, so this person is taking $200 a month and putting it away, it goes into the calculator as a payment of negative 200. So they have to somehow make a difference between getting money and investing money or putting it away. So your payment is negative 200. You're making monthly payments 12 times per year. It is also compounded 12 times per year. And if you put those values in and go up to n, which is what we wanted to find out, and above your enter button in green, and on mine it says solve, so I push Alt alpha and then solve, it figures it out to be 251.18, like that, without any logarithms, very quick, which is really nice to be able to do. Also, what is interesting in this situation, how much did this $100,000 cost you? Right? You put in 251.17 payments. 251.17. How much were each of our payments? $200. you got $100,000 for $50,000. That's a pretty good deal. It took 21 years. That's the bad part. If you have patience problems, right, then that's the bad part. Otherwise, if they said, yeah, we'll do this tomorrow, I was like, I'll get $50,000 for you tomorrow, and I'll exchange it for $100,000. Yeah, I'm good. I could do that. I'm pretty sure I can find someone to help me with that. But it took 21 years. Still not bad if you're willing to, if you start putting a little bit of money away already, it can grow to a large amount. And this was 6% interest, which is still a pretty good interest rate, but you can find things now, between 4 and 5%, you can find that. Whereas 2 years ago, I would say this doesn't exist in Canada. But now it's starting to exist again, because it's starting to cost more money to borrow money as well. Okay. This is example number 1. You can write down the questions 3. Circle 3 and 6.